Okay, now I have my data for Google Stock in my work environment. So let me just copy the path and read it as usual. Let me say P. Let me call it my Google Stock. Yeah, Google Stock data is pd.read.csv. Then I have it there. So let me read and see what I have. So I want to create the same thing. What I've done here, I want to create a heat map for correlation analysis. So I'm going to start writing my code. I'm going to say my correlation analysis, let it be from Google Stock data. Sometimes it's very difficult to copy from an Excel, from Python. So let me define my particular uh, columns that I want to check the correlation. So let me select close, open, and high. Maybe open. Let me set the open. Tunaanza na open. Yeah. Then the next one is close. Close. We have high. Mhm. Then you have low. I want my spelling correct. Do not copy that. So I'm going to plot my heat map. PLT dot figure. This will help me to identify the fig size if I wanted to. Then we'll say SNS dot heat map, because I want to plot my heat map, but for my data set correlation. And then I'm going to get my annotation to be true, so that all the labels will be inside my plot. So I'm going to say plt dot show. Let me show what I have. Same things. Just give it time to run so that we see what we have. It's now running the correlation analysis. Okay, it's a little bit okay. Oh, though it's not what I require. So let me run the correlation over here. I can decide to do that here, but let me do it here. Upper Jew, the correlation. So my correlation, I've accessed all these particular columns or entries. Then I'm going to get the correlation of them using the COR function. This is what I've done. So here's our heat map. This is what we have. This is what we have. And that's similar to what we had here earlier on. It's just an extension. So you'll be able to see how this particular mm, data columns or the variables relate by just checking them over the axis here. I mean, over this is like a key where you'll get this particular axis. So in most cases, the color here define what value is. For example, if we see black, there's a correlation of 1, perfect correlation. For instance, open and open, we have uh, there's a perfect correlation. Okay, for close here and close, we have a perfect correlation of value 1. That's why we have the darkest part as 1. For values of 0 point, let me take this light one. 0.99985. So this value increases upwards. The color here will help you identify the type of correlation. So remember what I told you earlier on correlation. Whether it's perfect, whether it's weak, whether it's positive, weak, positive, strong, all that. So that's based on the heat map itself. Come on. Not really, not really. But when you have two of them, they'll be indicated directly. But for us here, we have the scale. Easy colors which help you determine the house the center of the correlation. No, no, the color. Kama here, the darkest point is the one of the weakest, and it will improve upwards up to value 1. So if you see open here against open, there's a value here 1. Okay, 1. Why? Because that's the lightest color here. As you can see, that's why it's light. I will see that, Mr. Wilberforce. In our scale, this one against this. I will see that, Mr. Wilberforce. Yes, you're right. That's how it's done. Okay, okay. Do you remember the volume? The volume one behave differently. Let's now use the volume as well. Let's see how it behave for us to understand that better. I've gotten your concept. So let's include volume. Are you able to see that now? negative 0.56. Uh, yes, that's exactly that's true. That's true. That's true. For others, you if you remember back, we did a simple correlation using just a line plot. We're able to see that volume behaves differently. Volume behaves differently as the others. The others had a perfect correlation, meaning open determine close. By the way, in sales, your opening stock determine your closing stock, the amount of money you have in the at the end of the day. So there's a relationship between the remaining one: open, close, open, high, open, low, low against low against high, against close, all that. But volume is opens. I mean, work in an inverse man. The same way here. There's no correlation between science and math. That's we have a weak positive correlation. This one you have not strong, but this is a negative correlation. Doesn't matter. Volume doesn't have influence on the other. So that's it. You're correct. Points is at home. That's how it goes. Yeah. So by checking that, we'll be able to see this particular figures, and the colors here will determine just to label what's there. Okay. Now, unless there's any question from Mr. Manuel, Emmanuel umenyamaza sana. How is everything on your side? Sawa sawa. Oh yeah. Let's move to our next visualization. That's box plot. This is number C. Let me put it D. D box plots. But the box plots are commonly used in a number of times because you can a lot of purpose. For instance, earlier on I told you that we talk about outliers. Outliers. So box plot is a easier way for you to identify an outlier. What's an outlier? Okay, is the extreme point either lowest or the highest? I always give this particular simple example. I have an age group. I'm talking about people of the range 25 to 60, for example. Then amidst there's a person of age 5. Okay, in a minute, I have a person with age 5. While majority of us, 99% of us, we are of age between 25 to 60. But all of a sudden, in my data, I'm having someone of age 5. Or I'm having someone of age 100 or 110. So those two particular data points are what's called outliers. They're very extreme ends. They will really influence our data. So, box plot is a very beautiful way for you to identify or detect outliers. Because of time, later I'll share with you a very comprehensive notes. Whatever thing I'm talking about, describe there, so you'll be using it for your revision. Now, let me use the box plot just on the same data. I don't want to import any other, just using the Google stock. Let me check, right? Let me do a box plot for the closed column. Let me do a box plot for the closed column. So the same approach applies. Like I can define my figures. Can plt dot figure. This will let me define my fig size. All of us we know that. Can say 10 against 5 or against 6. Then I can say SNS. Let me call Seaborn SNS dot box plot. Then inside I'm going to pass uh, where my data is coming from. So for me, it's coming from I named the data, if I'm not wrong, or Google Stock. So this is my source of data. Uh, Control V, that's Google Stock. Okay. Then I'm going to define whatever particular column I want to check for outliers. So let's start with the close. Yeah. So essentially what I'm going to do in my particular column like this one here, containing hundreds and hundreds of record, I want to see is there any extreme value. Aya, ukiangalia hapa 49 na 53 they are almost the same range. I don't have problem with that. Is there something like 2 or 1 or 1000? So this is example of outliers. I've called my plot figure function. I've called box plot. So let me show my nini. Let me show my plot. I can give the title by the plot dot title. I would call it box plot of closing date. Let me show my figure plt dot show. So this is how actually a box plot look like. What's really happening? Must be not an integer. Come on. Okay. Let me stop passing these particular values for now. So this is an example of a box plot. By the way, box plot also help you to check the skewness of your data. Let me tell you how you interpret a box plot. How you interpret a box plot. Let me give a little theory. So in the middle here, we have some rectangle. We have a rectangle. So in this rectangle, you have a line crossing it here in between. So this particular line shows you where the mean lies. Okay, where the mean lies. Let me do something funny. So you can see here the mean of my close is at 380. 380, that's the mean. So if we check keenly, 380 will be something somewhere here before 400. That's where my mean lies. 380.0. So 380 somewhere there. The upper part shows you the median. Okay, the median range. Then we have a line here, okay, with a T like, I don't know, but once you can see that you're able to identify. The topmost shows you the highest value in our data set. Highest value. So this can be something like 1000. That can be my highest value, something like 1000. The lowest value here is maybe one something or 80. I wish that Mr. Mr. Wilberforce. Hello? Hello, Mr. Wilberforce. Can you hear me? Uh, oh, I can see the reaction. You are just right. So for our case, we're not having outliers. We're not having outliers. So let me just Google for you. a box plot with the outlier. So in outliers you will identify that after the line kuna some dotted, kuna some dots yenye inaonyesha extreme values. Maybe beyond 1000 there's something like 1 million. So you'll be having a dot depending on the number of outliers that you have. So let me just do a Google search. I show you how it looks like. In our data set, we're lucky there's no outliers. Outliers. Okay. Open in a new tab. Open image. Are you able to see my screen, Mr. Emmanuel? What about Mr. Wilberforce? Can you see my screen? Kwa mfano, tuko na number of box plots here for very many variables. Okay. Aya, here you can see that my mean is just somewhere here in the middle between 16 and 18, maybe 17. The mean for the first particular. Oh, I have temperature against hour. So let me say that. So here you can see I'm having a mean right somewhere there. My highest value can be this between 16 and 40, somewhere there. I'm having my highest value. Down here, I'm having my lowest value. Then, I hope most interest is on the dots. Are you able to see some dots there, Mr. Emmanuel? So, isn't these are outliers? The outliers. So, these are the outliers. Let me find for you another perfect example. Open image in a new tab. Okay, so I have something here. I don't know. It's ages of Oscar winning factors from 2010 to 2020. So you have been shown that these are the outliers. Dot dot. Able to see that, Mr. Wilberforce? Exactly. And I promised to show you that. So here is it. Yeah, yeah. So for example, what I can see here for male and female, these people are checking for male and female. Let me zoom a little bit. For male and female. So the at most age here for male, it can be something like 50. Can you estimate this, Mr. Manuel? Which age can this be? 50 something, huh? 50? The highest here. 54, isn't it? So the highest age for male was at 54. The lowest is around here, maybe 18 or maybe 19. So that for female here is 18. Okay. Then the highest is at 51. And then you have these outliers. All of a sudden, someone is having of age 80 something or 81. So those are outliers. That's what we've been shown by the dots. So for us here, let's go back. We were not able to see that because we don't have any outliers. Everything is within the range. There's no problem with that. That's how you interpret outliers on the box plots. So that's it all. Let's try with the let's check for open date. Let me run that and see. Yeah, so this tutorial for the open itself, we can check for, let's check for volume. Oh yeah, 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 yeah. Perfect, perfect. This is what I wanted. I got it. Mr. Emmanuel. Hello, Mr. Emmanuel. Now, are we now able to see the dotted lines on top? So these are the outliers now because you can see our highest value can be something like 3 or 2.5. Then all of a sudden there's someone with 8. Then the lowest is at 0. Maybe 1. And the mean is there at 0.3. Yeah. So this is how you do that. And by the way, these are just graphical visualization. You can be able to just check for the mean manual, like what I did earlier on. You can be able to check the mean, or you can even check for everything by calling the descriptive statistics. Describe. Describe. You can check for everything, and then you compare with whichever thing you have. The count, the mean, the median, the maximum. We are able to like the maximum is 989. 989. So let me take you back to my graph. For let me do for it was for for close. Acha nikuonyeshe tu dakika moja. I'm very interested in showing you this. It's not all about doing. The interpretation also matters. You can see my maximum value is at 898.667. That's approximately before 1000. I will see that, Mr. Wilberforce. That's my maximum. What of minimum? 49.66.68. Just below here, you can estimate that you have 49.68 as my lowest. Then my mean, okay, is at my mean is at 380. We saw this earlier around there. Yeah. Is there any question from anyone up to that? I want to talk about two last visualizations. That's the okay. Okay, that's a good question. Okay, that's a good question. Let me show you something. Let me show you something. Okay, are you able to see this, Mr. Emmanuel and Mr. Wilberforce? So this is an example of a box plot. Though it's horizontal, but the same thing we can apply with the maximum. So you have another mathematical intuition beyond them and how to interpret. So below here is the minimum. Here you can see it's negative 3 point something or negative 2.8. This is confusing. Never negative uh, 2.8 before 3. That's the minimum. The maximum is right over here. Maybe 2.9, somewhere there, or 2.8. Then that line shows you the median. The straight line shows you the median. Okay. The first point here shows you the first quarter. The last one here shows you the third quarter. So in the middle is where you have the mean. In other cases, mean that are being shown using dotted lines. Dotted lines. And let me show you another example. I hope you're able to see the outliers, the minimum, the maximum, first quarter, third quarter, and the medium. Just hold on up that point. So let me show another example. Okay, there's another example here. Are you able to see this, Mr. Wilberforce? Yeah. Okay, so in most cases, they will show you dotted lines to indicate that's the mean, while the straight line shows you the median. Again, Q1 is the first quarter, Q3 is the third quarter. Then now we have the normal outliers. A median of 42 means that half of the patients are older than 42. So that's now they're trying to indicate, to integrate, to interpret what median means. So from here, you have your scale, you're able to at least estimate. By box plot, you can able to estimate, but if you do the actual describe, you see the mean itself coming out clearly. Yeah. So this 42 right over there, and in other cases, so let's go back to our example. Okay, with here we have not been shown the dotted line. Why? We can get that mean actually by running the describe function. So you'll see that mean uh, clearly. So our mean is 380. Our median, I don't know what is here. It's not there. Uh, it's something around to 40 or to 30, something there. Okay. Then this is our first quarter, maybe to 5. Then our third quarter is it 500? Yeah, somewhere there. And then here we don't have any outliers. So dashed line shows you the mean, the straight line shows you the median. So this dashed line will just show us where the mean is. In most cases, I told you mean and median are always close. They should be close. If there's a big disparities, then there's a bias in your analysis. It should be close. So if you're able to estimate the median, you should also be able to estimate the mean. Without estimation, you can just run the statistical analysis to get you everything. So that's it. Let's use the remaining time here. I talk about the counter plot, count plot can be my last one. Count plot. So this number D E. Though there are a number of them that's remaining, like what's called violin, they're not commonly used, by the way. They're not commonly used. So these are the most commonly used. This should be count plot. Count plot. Okay, now let me work with another set. The Google stock one is now boring. Let me import the students and see how to work with that. Import pandas as pd, import numpy as compute, import Seaborn as SNS. Okay, I can integrate you there. Okay, let's leave it at that point. So let me read the CSV. I'm going to say my new data. Let me call it student data. Student data is equal to pd dot read is CSV. So then I'm going to pass my path. Students performance. And also remember that this particular file you have to store it somewhere. It is just temporarily stored here. Okay, let me just check the first few rows to ensure everything is perfectly loaded. Dot behead. Perfect. So I want to count the gender distribution. Okay, my task is to count the gender distribution. I have two gender. I have male and female. I want to see in my data how many female are we having and how many male are we having, and then I will show this using a graph. That graph is called a count plot. So I am going to do that. I'm going to say SNS dot count plot. Of course, I've read my data, so let me do the count plot. Then in my x-axis, I'm going to call the gender. Then in my y-axis, there on top is where I'm going to get my data from. It was students' data. STD. If I'm not wrong, let me see. Yeah, they have to be the same. So after that, I'm going to show plt dot show. Even without showing, I can include the title plt dot title. Let me call it gender distribution. That's a speed. Perfect. So let me run this and see what I have. Oh, I have my perfect count plot showing me the gender distribution for both female and male. So in my data, I can see uh, I'm having 500 and something, 540 female, while male I'm having around 480 something. Okay, I'm able to get that. So let me check back. Mhm. So I have a perfect count plot where I'm able to see the graph distribution for my gender. So I have female against male. So what are some of the insights that you can get from this? You'll be able to identify the frequency of mostly categorical data like gender. Gender can either be male or female. Okay. Day can either be, time can either be day or night. Categorical. Yeah. What else can I think about? Fail or pass. Those are categorical. Maybe you can count how many students have passed or how many students have failed. So count plot is a very beautiful way for you to display or show the distribution of categories. If you don't have categories, please don't. You'll have a number of them that will be difficult to show. Let me see about ethnicity or race. Let me run this. So this how my ethnicity has been grouped. Like group B, there are around 180 students. For group C, we have almost 320 students. For group A, I'm having around 80. For group D, I'm having around 260. For group E, I'm having around this can be 140. Huh? So I'm able to count or display the distribution for my five categories of ethnicity. Maybe think of it like tribe: Jaluo, Mkikuyu, Mkalenjin, Mkisi, which is remaining Mteso. Sijui kama Mteso ni Bantu, I mean ni Mloya sijui, something of that sort. So I'm able to count the distribution, maybe based on race or ethnicity. In Kenya, you can talk about tribe. You can able to see that. Maybe you're in an election or you're doing your what? You're doing a mini vote. You're voting to see how many people have voted. So you'll be able to count uh, based on those categories that you are investigating. So that's how you use the count plot. I want to talk about something. Let me do an introduction of a Google map. That's my last thing. I'm going to test your question. You'll ask me anything after this before we end the class. So let me just summarize up. Let me talk about maps. Let me talk just basic maps. Visualization. So this is one of the one of the rare most graphs. I mean, visualization that you can encounter working with the maps. So in maps, there's one more thing. No, if this can't sing to you, don't forget. Don't mind about it. Don't worry about it anyway. This is just a bonus. I myself I rarely use it because everything is done in the Google for maps. So I'm going to import what's called Folium for maps. There's a library for maps called Folium. Then after that, I'm going to define my map. I'm saying map is equal to this can be any variable. I can say map of Kenya or map of anything. Then I'm going to call my folium. Folium, let me call map. So for my folium library, I'm going to call my map function. So inside my map function, I'll be able to specify I'm having two options. The first one is the what's called the locations. I mean, how do you call it? Longitude and latitudes in most cases. Yeah. Let me just try that. Do that only before I pass the other one. See what's there. Let's see if it works perfectly fine. Let's see. Oh, I have my map here. I have my map here. The first thing it shows me where I am around. I'm around central. So I'm seeing Kiambu. Let me zoom this for you guys. So I can see Nairobi, I can see Kiambu, Ruaka, Kamba, Githunguri, Maimayu, Mount Suswa. Okay. For those who are doing census, this is how they are able to generate maps using maybe Python. So they can even give streaks or nini. They can highlight colors based on whatever thing they want to talk about. Mhm. So let me zoom back and zoom in. So I want to add one particular feature to avoid me zooming in and out. So I want to define my zoom. Let me go back. It's not scrolling, guys. Let me scroll here. So after passing my latitude or longitude for me, let me pass zoom. What's called zoom start. Can you keep it for like 10? Uh, Zoom start 10. Yeah. So my zoom is at 10, so I can either increase it or reduce it. Okay. So anytime I click on plus, it zooms 10 times by 10. That's like a scale. Okay. Nairobi. So let me pass a arbitrary point that I don't know. Me myself, I don't know. Let me just pass any particular longitude and latitude. Let's say negative 2 points, and then now we have 46. What place can this be? Let's see what it's giving us. Oh, Indian Ocean, around the Indian Ocean. So that's why I'm having that particular longitude and latitude. So somewhere there. Hey guys, don't worry about this. You won't be using this in your mostly in your daily lives, but you'll be interacting with this from maybe other sources. There are apps for you to just get that map whenever you are. So that's the end for our data visualization in Python. I want to ask if there's any other question from whatever thing that we've talked about, even from the start. I know I've talked so much. I've never given you enough time even to practice these things. I just wanted to complete this thing today. I know over the weekend we shall have time to do the practice. Hello, Mr. Wilberforce, are you there? Do you have any question on whatever things you have discussed?